Hello students, today in this video we'll discuss about the factor theorem. Before discussing about the factor theorem, let's recall what we have done in the previous video, that is the remainder theorem. We were finding the remainders by remainder theorem. So like we have taken any polynomial x raised to power 4, x plus x cube minus 2x square plus x plus 1. So it is divided by the another polynomial x minus 1. That x minus 1 should be linear for applying the remainder theorem. So for applying the remainder theorem, what we are doing, we are taking this polynomial as px and this another polynomial divisor. So for applying the remainder theorem, we have to find out the zero of this polynomial. Zero of this polynomial is what? X minus 1 will equate with 0. So we are getting 0 of this x minus 1 is 1. So by remainder theorem, remainder is equal to p of 1. Means in place of x, we have to fill 1. 1 raised to power 4 plus 1 cube minus 2 into 1 square plus 1 plus 1. So from here 1 plus 1 minus 2 plus 2. So we are getting remainder as 2. Similarly, we can do the other question by remainder theorem. So we are taking the polynomial x cube plus 3x square plus 3x plus 1 is divided by the x plus 1. This x plus 1 must be linear. So here you are seeing the power of x is 1, so it is linear. So we can apply the remainder theorem. So for applying the remainder theorem, we have to find out the 0 of this divisor x plus 1. So 0 of x plus 1 is minus 1. So by remainder theorem, remainder is equal to p of minus 1. In place of x, what we have to fill? Minus 1. So minus 1 cube plus 3 into minus 1 square plus 3 into minus 1 plus 1. So after solving minus 1 cube, we are getting minus 1. 3 into minus 1 square plus 3 minus 3 plus 1. So we are getting remainder as 0. So like this, we are getting the remainders by remainder theorem. So today we'll discuss about the factor theorem. So what do you mean by factor theorem? So factor theorem is if we are having any polynomial px, see this is the polynomial we have taken, polynomial px, x cube plus 3x square plus 3x plus 1 of degree n greater than or equal to 1. Greater than means it can be 3, it can be 2, and it can be equal to 1 also. This is a sign of greater than or equal to 1. And a is any real number. So here a is what? Minus 1. Real number means it can be rational, it can be irrational, it can be any number. So here a is minus 1. Then x minus a is a factor of px if p of a is equal to 0. So p of a is what? So p of a is not any other thing, it is the remainder. So see, so before applying the factor theorem, we are using the remainder theorem. We are finding the remainder. So p of minus 1. So what we are getting remainder? We are getting remainder 0. So since p of minus 1 is equal to 0, so by factor theorem, this x plus 1 is a factor of x cube plus 3x square plus 3x plus 1. This is your factor theorem. It can be vice versa also. Vice versa is what? If x minus a is a factor of px, then remainder is equal to 0. Means if we are given this x plus 1 is a factor of this polynomial, then your remainder must be equal to 0. So this is your factor theorem. Now let's discuss the factor theorem by solving some of the questions of exercise 2.4. Like see the first question. Determine which of the following has x plus 1 as a factor of x cube plus x square plus x plus 1. Now you will see that this is, we have taken the px. Let px is equal to x cube plus x square plus x plus 1. Now you will see this polynomial is having degree greater than 1. It can be 1 also, it can be greater than 1 also. So for finding that x plus 1 is a factor of this one, first of all we have to apply the remainder theorem. Always we have to find out the remainder only. So for applying the remainder theorem, what we have to do? We have to find out the 0 of the linear polynomial, that is divisor x plus 1. So 0 of x plus 1 is at minus 1. So in place of x, what we have to fill? Minus 1. So here what we are doing? We are doing the remainder theorem over here. So minus 1 raised to power 3 plus minus 1 raised to power 2 plus minus 1 plus 1. So after solving, what we are getting? P of minus 1, we are getting the 0. So here what we are getting? Remainder 0. So since P of minus 1 is equal to 0, that is remainder is equal to 0, by factor theorem, x plus 1 is a factor of this polynomial. Polynomial is what? X cube plus x square plus x plus 1. So similarly we can discuss one more example. Like see the fourth part. We are given one polynomial x cube minus x square minus bracket 2 plus root 2 into x plus root 2. So we are taking this polynomial, we are giving the name of this polynomial as px. Px is equal to x cube minus x square minus 2 plus root 2 into x plus root 2. So they are asking x plus 1 is a factor of this polynomial. So what we have to do? We have to find out the 0 of this x plus 1, that is divisor. So 0 of x plus 1 is minus 1. So in place of x, what we have to fill? Minus 1. Again what we are doing? We are applying the remainder theorem. So minus 1 raised to power 3 minus 1 raised to power 2. So minus 2 plus root 2 into minus 1 plus root 2. So minus 1 cube, what you are getting? Minus 1. Minus 1 square, what you are getting? 1. Now minus will become plus. So 2 plus root 2 plus root 2. So minus 1 becomes minus 2 plus 2 plus root 2 plus root 2. Minus 2 plus 2 cancel. So what we are left with? Root 2 plus root 2. Root 2 plus root 2, what you are getting? 2 root 2. So as when we are getting the 2 root 2, you will see since P of minus 1 is not equal to 0. So what you are getting? P of minus 1. P of minus 1 we are getting 2 root 2. So here P of minus 1 is not equal to 0. So by factor theorem, x plus 1 is not a factor of this polynomial. So this is your factor theorem. How you have to do this question. So like this, you have to do the remaining all parts. Similarly, we can discuss one more question, like question number 2. Use the factor theorem to determine whether gx is a factor of px in each of the following cases. Like I am doing the third part. So here third part we are given px is equal to x cube minus 4x square plus x plus 6. And gx, it is given x minus 3. So gx here, now you are seeing that it is linear polynomial. So we are finding the 0 of this gx, that is x minus 3 is what? 3. So now what we have to do? We have to apply the remainder theorem. In place of x, what we have to fill? 3. So 3 cube minus 4 into 3 square plus 3 plus 6. So 3 cube is what? 27 minus 4 into 3 square. 3 square is 9. 9 into 4, 36 plus 3 plus 6. So 27 minus 36 minus 9. 3 plus 6 plus 9. So what we are getting? Remainder we are getting 0. Since P of 3, that is remainder, is equal to 0, by factor theorem, gx is a factor of px. Gx is divisor and px is the dividend. So divisor is a factor of the dividend. So this is your factor theorem. So like this, you have to do the remaining all parts of question number 2. So now let's discuss question number 3. Find the value of k if x minus 1 is a factor of px in each of the following cases. Like third part I am taking. So px we are given k into x square minus root 2 into x plus 1. Now question is given x minus 1 is a factor of px. Means in this question we are already given that x minus 1 is a factor of px. So what we have done the factor theorem? If x minus a is a factor of px, then remainder must be equal to 0. So in this question also, we have to equate remainder equal to 0. So we are given x minus a is a factor of px. So therefore we are given x minus 1 is a factor of px. Therefore p of 1. P of 1 is what? That is 0 of this x minus 1. 0 of x minus 1 is what? 1. So P of 1 should be equal to 0 by factor theorem. Means now you have to equate remainder as 0. So like this, P of 1 in place of x, what we are filling? 1. K into 1 square minus root 2 into 1 plus 1. So in place of P of 1, what we have to put? 0, because we are already given x minus 1 is a factor of px. So remainder must be equal to 0. So 0 is equal to k minus root 2 plus 1. Now we have to transpose this root 2 and 1 on that side. Minus root 2 will become plus root 2. plus 1 will become minus 1. So what is the value of k? So therefore k is equal to root 2 minus 1 is the answer. Have you understood? So let's take one more example. See, fourth part. So we are given any polynomial px kx square minus 3x plus k. Now in this fourth part we are given x minus 1 is a factor of this polynomial. So we are already given x minus 1 is a factor. So as x minus 1 is a factor of this polynomial, so by factor theorem p of 1 is equal to 0. So p of 1, how we are getting p of 1? So we are finding the 0 of x minus 1. So 0 of x minus 1 is what? Is 1. So that is p of 1. So in place of x, what we have to fill? 1. And we have to equate remainder equal to 0. So in place of x we are filling 1, k into 1 square minus 3 into 1 plus k. So p of 1 is equal to 0 because by factor theorem. So in place of p of 1 we are filling 0, k into 1 square 1 only. So we are left with k minus 3 into 1 minus 3 plus k. So now k plus k becomes 2k minus 3. So transpose 3 on other side, it becomes minus 3 will become plus 3 is equal to 2k. Then transpose 2 on this side. 2 is multiplied with k, so on that side it will be divided. So k value what we are getting? 3 upon 2. Therefore k is equal to 3 upon 2. So like this you have to do all parts of question number 3. Thank you.